Okay, so let me go back to this prerequisite chain. So as I said previously, every course you're supposed to take is put there to teach you something, um, and it may not be obvious at first. So you may not see why that course may be important for being an engineer, but so as I said, a lot of thought has been put on these things, and it's a result of years of experience, not just from our university, but from around the world. So if you go to, well, our system is closer to American system. So if you look at American universities, you will see that their curriculum is not too different from ours. You will see very similar courses. So every course is really important, and you need to learn every course. But within every course, I think the best thing is to try to see what you are supposed to learn in that course. At the beginning of each course, I suggest that you take a look at the course contents and try to understand what you will be learning. So you'll be taking these 5 courses, and I suggest that you take a look at the course syllabus, the topics that will be covered in that course, and think about that a little bit. So I will be doing that for this course, but it will really be helpful if you do this for every course. And okay, so let's start with the title of the course. Let's see what the title says. It's Introduction to Aircraft Performance. It's an introduction course, so you'll be starting to learn about aircraft performance. It's not like you'll be learning everything about aircraft performance, but you'll be getting some introductory information. So that's why it's called introduction. And it says aircraft performance. So now we should really think about what we mean by aircraft. You all know what an aircraft is, but let's take a look at a technical definition. So aircraft are vehicles which are able to fly by being supported by the air. An aircraft counters the force of gravity by using either static lift or by using the dynamic lift of an airfoil, or in a few cases the downward thrust from jet engines. Now let's go over this again. Are vehicles which are able to fly or move through the air by being supported by the air. So this is a critical part of the definition. So if you throw something out, it will be moving in the air, but you can't call this aircraft unless the air supports its motion. Otherwise, if I just throw this bottle, it will just move in the air and then it will fall to the ground. It will be just doing projectile motion, right? The air, the forces coming from the air has no contribution to its. Basically, it's not really supported by the air. So for something to be aircraft, air has to be providing the force for that to stay in the air. There are 3 methods of creating this lift. Well, the aerodynamic forces to carry the weight of that object can be coming from 3 different methods. These are static lift, dynamic lift, or thrust force. We will be talking mostly about the dynamic lift concept. The static lift and thrust force, they are used for some aircraft, but they will not really be covered in this course. And then the title says Aircraft Introduction to Aircraft Performance. So this is how we define an aircraft. Basically, it's a vehicle that can move in the air by supporting its weight using forces created by the air. And when we say performance, we basically mean how well it moves or how well it flies. This is an engineering course, and in engineering, whatever we do, we use some scientific terms. Okay, so we don't use terms like it flies well. It's not a valid engineering assessment, right? So we need to define it using numbers, basically. And we'll be to that end, we will be considering certain items that defines the performance of an aircraft. For example, one of the things that determines the performance is its speed. Okay, so how fast can it fly? So if you say this aircraft has a good performance, instead of saying a good performance, we will be defining it using quantitative terms. So we will be defining the maximum speed it can reach. So this is one of the things that determines its performance. Another thing we will be studying in this course will be the maximum altitude. So it can stay in the air, it can move in the air, but is there a limit to how high it can go? So obviously there is a limit to that. It cannot really go to space. And we will be studying by using equations what is the maximum altitude an aircraft can climb to. So this is one of the things we will be studying in this course. Another important performance number is its range. How far can it go? It's a very important performance number. For both civil aircraft and military aircraft, range is a very important parameter. So if you want to go to United States, for example, it's good if you have a very long range aircraft. So you can take off from Istanbul or Ankara and then directly fly to United States without having to refuel. Similarly, for military aircraft, it's important as well. If you have a long-range military aircraft, that aircraft will give you the possibility to go to long distances for military operations if you need to. Another thing which is related to range but not really the same thing is the endurance. So this is defined as the amount of time an aircraft can stay in the air. So for certain things, you care more about endurance. For example, for search and rescue missions, you want to be able to stay as long as possible. So if you are looking for somebody, for example, from the air, you want to be able to stay there as long as you can. You want long endurance there. You don't care about going to a long distance, but you want to stay in the air for a long amount of time. Another thing is its climb performance. So we will be studying this as well. Being able to climb faster is important for both, again, civil and military aircraft. For civil aircraft, it's important because the airports are now in big cities, are very close to cities, and you don't want to fly at a low altitude on a big city because of regulations. Okay, so there are some noise regulations. You don't basically a civil aircraft, especially when taking off from an airport close to a city, you need to climb as quickly as you can so that you will be above the city. Obviously, for military aircraft, it's important as well. If there's a threat that can attack your aircraft, then you want to climb as quickly as you can so that you'll be out of the range of enemy fire. Descending is another subject we'll be studying. Well, I don't really talk about this anymore in this course, how quickly it can stop on the ground or how quickly can it take off. And we'll be talking about these last two topics as well. These will be the last subjects of the semester, and we'll be talking about the turning performance of an aircraft. This is more important for military aircraft. You can call this maneuverability. How well an aircraft can maneuver is an important aspect in its performance. So we will be studying this as well. How quickly an aircraft can make a turn, or what's the minimum radius of turn. Okay, so we will be studying this list except for this these two items here. So we'll be studying these by using equations. Okay, so I will show you some simple equations. By using these equations, we will be calculating, we will be obtaining some numbers for all these performance measures. Okay, do you have any questions? Well, let me just say something. The equations we use in this course are simple. In fact, they are so simple that you may be disappointed that the performance of an aircraft is assessed by using such simple equations. Obviously, we make some assumptions we make some approximations to use those simple equations, but believe me, they are very accurate. Even though they are such simple equations, they are accurate enough that even when designing real aircraft, those simple equations are used and they give very good results. For example, to estimate the range of an aircraft, we will use such simple equation and we will say that, okay, the range is, I don't know, 1,000 kilometers. Obviously, that will be an approximate number. And if you take that aircraft and really fly, the actual range will be different, maybe less or it may be more. But the errors involved are really, really small. I mean, for some cases, there may be like maybe 10% error at most, but for some cases, they are even more accurate. So even though we will be using really simple equations, they are very good. They give very good indications of the performance, and these equations are used in aircraft design. Speaking of which, let me talk about the textbook. If you look at the syllabus I sent you with email, so hopefully you got that email yesterday. There's a textbook written there. That textbook is not really necessary for this course. That course is actually written for more advanced aerospace engineering students, and for first year it's a little bit complex. But if you are an aerospace engineering student, then it's a good idea to get that book, because you will use it for your future courses. But if you are just taking this course, then you don't have to take the book. I will not really be using that book a lot, because again, it's for third year or even fourth year students, and it's written towards designing an aircraft. But since the same equations are used, well, maybe in a little bit more simplified form, it may help you for this course as well. Okay. So this is what this entire course is about. This part where we will be calculating all these performance things is the second half of the course. Maybe more than the half, but in the initial part, for the next 2 or 3 weeks, maybe even more, before I start talking about these things, I will be giving some general information about aircraft. So we have some time. Maybe we can start talking about these lift concepts. So this is the definition again. As I told you that there are 3 different ways the lift force can be created. And remember, this lift force is required to carry the aircraft, basically, as you see in this picture. So every aircraft has a certain weight, and you need to balance this weight so that it can stay in the air. In the static lift concept, the necessary force to balance gravity can be created when the air around the aircraft is static. So there is no motion. The air is steady, and you can get this lift force in such a steady atmosphere. The static lift is created by using the buoyancy concept. In physics, buoyancy is an upward acting force exerted by a fluid that opposes an object's weight. So basically, if you have an object surrounded by a fluid, and if the density of the object is less than the density of the fluid, as you know from your physics courses, then that object will float in that fluid. So that's how the static lift concept is is used. This idea works well if your fluid is water, for example, because water is a really dense fluid, and it's easy to have objects that are lighter than that have density that's lower than the density of the water. So that's how boats float underwater. But if you are if your fluid is air, which is the case for aircraft, then you need to create an object whose density is less than density of air, which is already very low. So the aircraft that use the static lift concept are called lighter than air vehicles, and they are simply abbreviated as LTA. So when you hear this LTA, that means an aircraft that uses the static lift concept. So for LTA aircraft, you have a large container filled with a substance that is lighter than air. So here you see some substances that are used to create a density that is lower than the density of air. Among these, perhaps the most popular one is the hot air one. The first balloon flight was made quite a long time ago. So it was in France, November 21, 1783. So this is the first known balloon flight with people in it. And nowadays you see some interesting designs. You see balloons with all sorts of different shapes. So this is an unpowered aircraft. So you have this large container, and you fill this volume with a substance which has a density lower than the air density, and that carries the weight. Okay, so it gives the lift force, but that's the only thing you have. You have no control. You have no way of making forces to control this aircraft. So the flight of such a vehicle is determined by winds. So if you have winds in certain direction, then your aircraft will be going in that direction. You may have some control, as you see here. Here you have some devices here that can give you additional forces to control the motion. So these are the examples of aircraft that uses the static lift concept. And as you know, these are very popular for sightseeing. It's a very good idea to actually look around, because they are more efficient. So you can stay afloat in the air with a helicopter, but in a helicopter you need to burn a lot of fuel to do that. But if you have a hot air balloon, you can do that in a much cheaper way. You don't need to burn a lot of fuel. You just need to have the hot air. The other concept is the dynamic lift concept. So this is what most aircraft use. Here, the necessary force to balance gravity is created by the motion of the air around the aircraft. So in this case, as opposed to the static case, you need air, but the air needs to be moving with respect to your aircraft. And that's how you can create the lift force. And the last concept was the thrust force, remember? And in this case, the force to carry the weight of the aircraft is created by the engines of the aircraft. So the engines create thrust force in the vertical directions to balance the weight. And there are only very few aircraft that use this concept. And as I said, a very big majority of the aircraft that you know use the dynamic lift concept. So in the first weeks, I will be spending some time to explain you how this dynamic lift is created and how that works, how you can use that to fly an aircraft and to control an aircraft. I mean, just staying in the air by itself is not all that useful. You want to be able to go in any direction you want. So for that, so I'll be explaining those things, and this takes about 3 weeks or so, and then I start showing you the equations to calculate the performance. Do you have any questions? Well, I really feel like I've spoken a lot for the first day, and I don't really want to go any further. I can feel that you are already really bored, and the thing I would like to talk about next is really important. I'll be talking about the dynamic lift concept, and I would like to show you some interesting videos. So probably I would rather stop here and then start talking about that on Friday. Do you have any questions? Okay, so I will continue on Friday with this, and keep checking Matthew online for the information about the course, okay? So I will see you on Friday.